Welcome to the video for 1.4, polynomial functions and rates of change. This is Coach Meinbauer. Before we get started here, I have one reminder for you. Make sure that you like and subscribe. Okay, so for polynomial functions and rates of change here, we're going to be learning some new lingo from Algebra 2. A couple of things, though, that are not new is just talking about what the degree is, how to recognize what the degree is, what the leading coefficient is. So if you look in this upper box right here, you'll see that it gives us technical definitions. Okay, all this really says is that the largest powered is going to be where I locate my degree in my leading coefficient. Okay, so that's all that stuff says here. So let's just really tackle these examples because again, nothing is going to be majorly new here so far. So for example, first example for number one, we got p of x is 3x to the fourth plus 2x to the third plus 7. Now, I underlined 3x to the fourth because that is the highest power, fourth degree. There's no degree higher for all p of x. So I'm going to say that's degree 4. Leading coefficient is the big old number that's in front of the x. In that case, it's going to be a 3. Nothing new here, okay? Now, is it always the first term? No, it could be the last term. It could be a middle term. For the next one here, what is the degree of q of x? Oh, very good. You got 3. It's in the back here. If you notice, I'm boxing that minus sign in front of it. The leading coefficient is not 2, but it's a sign associated with that, so it's going to be negative 2. All right. Nothing new. Let's get to some newer stuff here. So relative extrema, same thing as local extrema. You're going to see both those words being interchanged, so be aware of both of them. So a polynomial has a relative minimum or relative maximum where it switches between decreasing and increasing or at an endpoint. If we have an endpoint, it could be a relative extrema as well. And we'll talk about whether it's a min or max. Okay. That being said, by that definition, let's look at this graph right here. Let's go ahead and find our local mins. So our local mins, I always start with the valleys. The valleys, which means that's two things that kind of come together at the bottom here. And I'm going to notice there's one right here. And that's it for in between the endpoints. Now, I do want to kind of emphasize one thing here. This is an arrow, which is going on forever and ever. So please take note of that. Okay, so at that point right there, that's going to be a local min. I actually have another spot for a local min. It's actually going to be at this endpoint right here. So local mins in AP PreCalculus can be at endpoints, or they can be obviously anywhere in between the graph. So our local minimums are going to be at x equals negative 4 and x equals 0. Local maximums can be different. Again, it's the top of the hill. Okay, so local maximum there at that blue, and then a local maximum at that blue. It's going to be a local max is at x equals negative 2 and x equals 3. Now, if you notice here, I didn't include this endpoint right over here, and I'll kind of highlight it just so you know what I'm talking about. There's no oh, what the heck is going on here? There is no relative extrema there because it's not an endpoint. It's an arrow, so it continues. Okay, so that's the local stuff. Let's get to the absolute extrema, also known as global extrema. Okay. So absolute extrema is the greatest value, and that's it. The highest value is the absolute maximum. The lowest value would be the absolute minimum. Okay. So at least all the local minima so the greatest of the absolute is the maximum. The greatest is the absolute maximum, and the smallest is the absolute minimum. Okay, so this one, for this graph right here, I'll zoom in a little bit for us. The absolute max, the absolute highest point is going to be in blue right here. Let's answer this question appropriately. So the absolute maximum that's the y value. The maximum is 2, located at x equals 3. absolute minimum. That's the lowest. Okay. Now, I know what you're thinking. You're thinking a couple things here. You're like, oh, coach, you're going to have an absolute minimum there where I just circled it. Or you're like, coach, you're going to have an absolute minimum there where I just circled it. So what I just circled were both local mins. But this continues on forever and ever and ever. So let me get rid of those little circles. And actually, I'll keep drawing this graph as if it's going on forever. So this is going to keep coming down forever and ever and ever. What's the lowest point? There is no lowest point because it goes on forever and ever. So technically, there is none. So I'm going to I'll put NA for not applicable because there is none. There ain't none. Now, I'm sure what you're thinking, like, coach, what do we do put on for a test? Well, it won't be like, hey, label the absolute minimum or label the absolute maximum. It will be, is there one, and stuff like that. So don't worry about how it's being asked. Just understand that there is no absolute minimum because that arrow keeps going on forever and ever and ever. Okay, let's kind of combine those two ideas together here. So we got relative minimum. And by the way, I'm going to just do this. Try this on your own. Hit pause. And then see what you get, because I want to go through this pretty quickly. Okay, so ready, set, pause. Oh, welcome back. So these are the answers I'm getting. I'm getting the relative. Actually, I'm just going to just kind of circle my extrema here. In pink, that's my extrema. It looks like, oh, I got extrema right there, extrema right there. Those are all my relative extrema. So my relative mins are my lower ones, which is going to be here at -3 and 3. I'll keep those in pink. I'll just keep these maxes in blues. So this is a max, this is a max, and this is a max, because these are all endpoints. So I have relative maximum at -4, at 0, and at 5. The absolute min is going to be this value right here. Oh, you can't see me circling it. It's going to be this right there where I just circled. That's going to be the absolute min. That value is -3, and it happens to be at x equals -3. The absolute max is going to be right here. It's the highest point. So the max is 4, and it happens at x equals 5. So there you go. There's extremo. Let's see what else we got here. Oh, use technology. I didn't even have this planned out. So, sure, we'll go ahead and use technology with you. So we're going to go ahead and graph this function right here. Go ahead and do that in calculator. I actually cannot do that. I did not set up the video for technology. So what you're going to do is you're going to graph this. And then I will take out my technology here and graph this, and I'll kind of show you what's going on. So go to your y equals, and you're going to, so go to your handy-dandy calculator, go to your y equals. Is that mirror imaged? Well, whatever. You get the idea. Type in x to the 4th minus 5x squared plus 1, and then you're just going to graph it. I hit zoom 6, and then it'll give me a standard graph. Again, I think mine right here is going to be a mirror image of what you have. Okay, but it should look like that from the zoom 6. Just to kind of give you a little bit of a sketch. It looks like this. Okay, so what we're going to do here is look for the absolute maximum together. Now, the way that I drew it, you should be able to tell that, well, there is no absolute max. Why is that? Because this goes on for infinitely above. So I'm going to put NA. And the directions do say that, which is kind of nice and convenient for us. Absolute minimum value. So I see 2 local mins. Now, it's hard for me on my graph to tell which one's lower. So I'm going to find both of those. So there's a min there and a min there. Okay, so you're going to use your calculator. Hopefully you know how to do this. Your calculator has a trace button. right here. Okay, hit the second trace, so pull up the calc options. And then you get all these choices. Again, sorry, it's a mirror image. I don't know, technology. And you're going to hit minimum. Okay, and then you're going to get this little cursor. Okay, you need to move the cursor close to where the minimum is. So I'm going to move it on to this guy right here. Again, mine's a mirror image. Hit enter for the right bound and left bound and guess. Okay, this is something you don't know how to do. You probably need to go in for tutorials or go ask your Algebra 2 teacher, Algebra 1 teacher how to do that. So what I'm getting is I'm getting this pink point right here to be the point negative 1.581. There's more decimals. So I'm going to put ... comma negative 5.25. So that's that coordinate point. Okay. I'm going to do the same thing to find the other side. And this happens to also be right over here. 1.581 ... That ... means there's more numbers available to us. We don't have a round till we're done with our answer. Comma negative 5.25. Okay, so they actually have the same y values right here. So they have the same minimum value, the absolute minimum value. So that's going to be negative 5.25. Okie dokie. Let's move on to points of inflection, which looks like this is our last part right here. Point of inflection, super simple, just when concavity changes. Okay, we go from concave up to concave down, point of inflection. Concave down to concave up, point of inflection. So what we're going to do here is we're just going to identify where our points of inflection are. So they just give us some dots. Now in pre-calculus, we don't have the capabilities of finding exactly where that happens. That's a calculus topic, but we can do pretty good estimating of seeing where we change. So what I'll do is I'll draw concave up in pink here. So it looks like we're concave up right here. So I'm going to trace this from here to here. It looks like it's pretty much concave up. Oh, and then from here to here. Up like a cup. Don't forget. Up like a cup. And then in blue, I'll do concave down. Which looks like it's from here to here. Okay. Point of inflection. I changed concavity, and I'll highlight that in this big old black dot right here. Looks like I'm changing concavity at those two spots. Those are my 2 points of inflection. So what are the x values of those? Again, it's going to be hard to tell on a graph unless it's pre-labeled for us. Luckily, pre-labeled here. So we're going to have points of inflection at B and D. Okay. And that's going to wrap up this video. Don't forget, like and subscribe.